Hi guys, and welcome to Magic. My name is Thomas Hansen and I'm one of the magicians over at servergardens.com, and in this video I'm going to show you some of the scalability features of Magic. Now if you want to reproduce what I'm doing in this video, you're going to need version 9.8.3 that was released like 20 minutes ago of Magic. Make sure you have that version if you want to reproduce what I'm doing in this particular video. So first things first, here I have the terminal open. Now if I do ls space -l, I list every piece of information related to every single file within my files folder. And as you can see here, I've created a foo.md file, which is basically 54,600 bytes large. Then I have created an endpoint in HyperIDE called mirror.post.hl, which basically contains these 4 lines of code. Basically, it accepts application /octet stream. It could be text /plain too. Anything that's not JSON or URL encoded parameters, etc., will not be attempted to be converted or loaded into memory by the Hyperlambda endpoint by default, implying I'm basically getting a stream in here as my arguments. Then we can have a look at foo.md. As you can see here, here's the file. It's 11,071 lines long. It's basically just my readme file repeated like 1,000 times or something. And more importantly, as you can see here, I have an interesting piece of Hyperlambda snippets, which basically iterates 1,000 times. Then it transfers to this endpoint, which of course is my backend. As you can see, localhost :4444. What I'm doing here, I'm basically using Docker for the record. I'm passing in content type equal text plain, file name equal foo.md, and then I'm decrementing the counter, ensuring that I'm actually iterating 1,000 times here. Now let's put that number into perspective, because what this endpoint basically does, it takes whatever it is given and returns back to the client. Now we know for a fact that my file is 54,600 bytes large. Then we know we're transferring it back and forth, implying we have to multiply that number by 2 to get the total bandwidth consumption, plus of course the HTTP envelope headers. However, I'm going to ignore them for the time being. Then we know we're doing this 1,000 times. Okay, that's 1,000 times. Then let's divide that number by 1,024, at which point we're given the kilobytes transferred. Then let's divide that number by 1,024, at which point we're given the megabytes. So I'm basically transferring 104 megabytes here. Of course, I am doing it over the local host network adapter. However, that's not what I want to illustrate. What I want to illustrate, which I actually can't illustrate in this video, but you can do it in Visual Studio if you have Windows, you can actually reproduce it and open up the profiler as you are executing this if you want to reproduce it, is that neither your client nor your server use any memory whatsoever. Why? Because the file is never loaded into the memory, neither by the client nor by the server. If you had created a traditional solution, loading the file, transferring it, then loading the response, loading the request on the server and returning the request, etc., etc., basically your web server and your client would probably crash. So let's have a look at how this works. Okay, so here I have my snippet. Let me do Chrome Inspect Tools and choose the network tab here, and let's execute it. Yet again, I'm transferring 104 megabytes. .8 seconds. Now, of course, if I had a profiler profiling the memory consumption on my computer now, I wouldn't see a dent in it. Because it doesn't use any memory whatsoever. Because it's just an intelligent consumption of streams. You see, first of all, the invocation here, which I have, well, actually I have it here. This thing here ensures that the file is never loaded up into memory by the client, but the stream is actually passed directly onto the HTTP request stream created by my http.post invocation. And then I'm associating a header with the file. On my client side again, on my server side again, I'm getting the file as a stream object, which is basically just returned immediately back here, right? So this allows me to build API gateways and things like that without ever as much as making a dent in the memory consumption of my server or my client for that matter. So anyways, that was a little bit of a performance feature in the latest version of Magic, version 9.8.3. I just released it 20 minutes ago. If you want to reproduce what I'm doing here, you can probably easily have a look at the code here, copy it into your own Hyper ID and copy this little snippet here too. Thanks for watching. Have a nice day.